Hi, this is Kaylee, and let's talk about a method we use in physics if we have multiple vectors that we have to figure out the resultant of. And it's called the resolution of components. And it's an alternate method that we can use instead of something like the law of cosines. The first step is simply taking whatever vector you're given and breaking it up into its component pieces. So for this one, we're going to start off really easy. On this one, we've got two vector components, 80 meters east and 30 meters north. And we're going to break them into their horizontal and vertical pieces. 80 meters east, we're going to break it into its vertical and horizontal components. The whole thing is horizontal. There's no vertical component. For the 30 meters due north, again, there's no x. It's just all vertical. Well, we simply add those together and we get that it's 80 in the x direction and 30 in the y direction. Now, if it was going south, that would be a negative direction, or if it's going west, that would be a negative direction. We kept it all here, and so we just add them together, and then we can do our Pythagorean theorem and tangent method to get the resultant. Oops, 30 squared. And so 80 squared plus 30 squared equals 7300, but that's r squared. Take the square root, we get 85.44 meters. And for the angle, we'll use tangent. Tangent theta is opposite over adjacent. And remember, we're always finding the angle from the original one to our resultant. And so in this case, tangent of 30 over 80 then take the inverse of that, so theta will equal 20.56 degrees. When you do this, it'll be the arctangent of 0.375. So the resultant would be 85.44 meters at 20.56 degrees north of east. Well, we didn't really have to do resolution components for that one. We could have just solved it normally. So let's try one where this method would be much more feasible and useful. Let's start off again with ones that are at right angles to each other and show you how this works. Alright, so I've got my table here. We're going to break this up into the x and y components of each vector to see what we get. So for the first one, we're going 20 meters due east. Well, for that one, it's all in the x and nothing in the y. We've got 30 meters due north. So if I try to do it graphically, we've got nothing in the x and 30 in the y. So we go 5 west. So again, that's all in the x, but that's going back the other way. So that's going to be minus 5. Nothing in the y. And then we're finishing out with 10 due south. So nothing in the x, and south would be negative 10. And we want the resultant. Well, the resultant will be from the first one to the last one. So that's r, and that's theta. to figure out the resultant, that could be complicated since we did all this. We can do it graphically and just measure that in the angle if we draw everything to proportion. But if we didn't, like I didn't, I just sketched that out, we'll need a method to solve that problem. So resolution components says list all your x, list all your y, making sure you keep the direction right. So positive x versus negative x, positive y versus negative y, and just add them together. So this is going to be 15 in the x and 20 in the y. Then you draw your new triangle to those dimensions. So we went 15 in the x and then 20 in the y, and we want the resultant, which is that. So again, now we're back to something we can do with Pythagorean theorem and tangent. So r squared equals a squared plus b squared. We've got 15 squared plus 20 squared. 15 squared plus 20 squared equals 625. But take the square root of that, and we get 25 meters. And we use tangent to figure out the angle. So tangent of theta is the opposite over adjacent. So in this case, that'll be 20 over 15. And we want the angle, so we're going to use the arctangent or inverse tangent, whichever one you prefer to call it, of that. And we get that theta is 53.13 degrees. So we get a resolution of 25 meters at 53.13 degrees north of east. And from my sketch, it looks like it should be somewhere in there. But since I didn't draw this out to scale, I can't trust it with measurements, but I can't trust the math with this. Well, again, that one's not too difficult. You can probably work that out without knowing the resolution of components method. But let's do one where it's going to be really handy. We've got two vectors that aren't at right angles to each other. So let's take a look at these. We've got one that's 300 meters, 30 degrees north of east. So 300 meters, 30 degrees north of east. And then from there, we've got one that is 400 meters north of west. Restart on that. North of west. So somewhere around there. And 400 meters. Now, one thing you can do is if you're trying to do it graphically, and obviously I didn't draw this to scale, so I can't trust it. So I don't know if this is going to end up over in the first quadrant or in the second quadrant. But what I can do is take those two vectors. Let me redraw down here. Again, not so much to scale, just to get the directions proper, because I am going to break them down into their components. And when I do, I can add them together. So I need my X and my Y components. So for the first one, I need to know the X and the Y for it. For the distance in the X, I want distance times the cosine of the angle. So that's 300 cosine of 30 degrees. We get 259.81. In the y, we're going to have the sine, 300 sine of 30 degrees. So in the x, we have 259.81. In the y, we've got 150. Let's do that with this one. We've got so much in the x and so much in the y. So dx for that one would be d cosine of theta. So that's 400 cosine of 40. So 400. So 40 cosine times 400 gives me 306.42 meters. And for the x, or sorry, for the y, we're going to use sine. So 400 sine of 40 degrees. And now we can add that to this. So the x is actually going the other direction. It's going west. So that'll be negative 306.42. The y is still going north, so that's still the positive direction. So that's 257.12. And we simply add them together. 150 plus 257.12 gives me a total for the y of 407.12. For the x, 259.81 minus 306.42 gives me negative 46.61. Now I'm going to use those two to draw my new triangle. Again, I'm going to start off with the x. So if I draw my crosshairs in, I would go 46.61 to the west, and then from there up, that'll be 407.12 meters going straight up. And I'm looking for the resultant, which will be from where you start to where you end, r and theta. Keep it in mind the direction I'm going. So r squared equals a squared plus b squared. So 46.61 squared plus 407.12, and that's got to be squared as well. This is why we have calculators. So 407.12 squared plus 46.61 squared equals that number, 167,919.87-ish. Then we're going to take the square root. So r is 409.78 meters. And to get the angle, we're going to use tangent. So tangent of theta, opposite over adjacent. So tangent of theta would be 407.12 divided by 46.61, or 07.12 divided by 46.61 gives me that number, 8.7346. Yeah, I want to take the arctangent of that. 7, 3, 4, 6. And I get 83.47 degrees. So that means my resultant is, let's put it right here. The resultant of those two vectors is 409.78 meters at 83.47 degrees north of west, because we were heading in the west direction and then up. So there's my final answer. Now, in trigonometry, you would use law of cosines, which can get pretty hairy on its own for just two vectors. But for this method, I can have a third vector and a fourth and a fifth. And I just keep adding lines to this, summing up each column, and then drawing a new triangle from that and getting the hypotenuse and the angle for that new triangle. It doesn't matter how many vectors there are, you just simply use the same process over and over again, where in law of cosines, it becomes a real headache after two vectors. Thank you for staying tuned to this very mathy video, and I will talk to you later. Goodbye.